Hello class, Dr. Yeager here. We are continuing on with our discussion of plate tectonic theory. We went through the whole spiel, how we went from rigid earth theory through Wagner and continental drift all the way through World War II to plate tectonic theory yesterday. I just wanted to take a minute today and go over the actual boundaries of plates, because different things happen at different kinds of plates. We are familiar with this image from yesterday. We remember that we had divergent plate boundaries, or plate boundaries that are moving apart from one another out there in the middle of the ocean, where we had that seafloor spreading stuff going on. You guys remember about that? And then we found these deep trenches where we had two plates coming together, right? Those deep trenches were where dense oceanic plate was getting pushed underneath, what we call subducted. It was getting pushed down underneath less dense continental plate, because when the two plates come together, the dense oceanic plate gets pushed underneath. And it causes those big, deep trenches. It also wrinkles up the crust and causes volcanic mountains, which is high volcanic mountains, wherever there is a convergent plate boundary. Now, your blue book calls that a colliding plate boundary for some reason. I don't know why, but it's okay. Converging and colliding mean the same thing. And then there's a third plate boundary that we haven't talked about yet, called a transform plate boundary, that we will talk about here today. Okay? So let's go through divergent plate boundaries first. We've talked about them already a little bit yesterday. It's where two plates pull apart from one another. And when the plates pull apart from one another, now it's important to understand this. A lot of times when people think about these plates, they think about them as being completely separate. Like, here's one plate, here's one plate. They might like be close to each other at a plate boundary, but they don't actually touch. Like, you could walk up to the edge and just look down into the center of Earth, right? And that's totally not the case. Think about these plate boundaries as a weak area between two sort of semi-connected plates. And when they're trying to pull apart from one another, they don't just move farther and farther apart. It pulls and stretches and deforms the crust there, so the crust gets really thin. So at a divergent plate boundary, like we have out there in the middle of the Atlantic Ocean, we have that ridge being formed, and that ridge forms because as this plate moves this way and this plate moves this way, you've got this thin, weakened section of the crust right here, and it gets so thin and it gets all fractured and it gets all weakened, so much so that this super hot molten crust that's down underneath the lithosphere, since it's hot and it's molten and it's not very dense, so it wants to rise up. That stuff can rise right up through this weakened part of the crust right at this plate boundary right here. And when that happens, well, this stuff comes out onto the ocean floor down there, of course, where it's really, really cold. So it is going to cool down into rock really quickly. So this is where that new oceanic crust forms, and it forms that ridge down there. But it never gets too high, because it builds up a little bit, but then it immediately starts moving off this way or moving off that way. And so this ridge down there never gets really, really high, even though it's constantly building new crust down there. So we call these divergent plate boundaries constructive plate boundaries. And we call them constructive because that's where new crust is built. Okay? At a divergent plate boundary, new crust is created or constructed. So we call them a constructive plate boundary. About the only landform that we really associate with divergent plate boundaries is what's called a mid-oceanic ridge, and we've talked about those. Those are those long lines of hills that form right at the plate boundary. And these divergent plate boundaries almost always happen they're almost always found at the bottom of an ocean. However, there are a couple of exceptions, and these exceptions happen when you have a divergent plate boundary that happens on a continent. And that happens in a couple places. The biggest or the most notable divergent plate boundary on a continent is happening on the continent of Africa, where basically the eastern part of Africa is pulling away into one direction, and the northern and western part of Africa is pulling away in a different direction. And so when that happens, the same thing happens. The crust gets really thin, and molten crustal material can move upwards. So you get this very thin valley that forms, and you do get some volcanoes that form there. But for the most part, you don't get the formation of big mountain ranges or anything like that. When you think about divergent plate boundaries, it's okay to think about them primarily as being associated with things that happen at the bottom of the ocean. Now, convergent plate boundaries are different. Convergent plate boundaries or colliding plate boundaries happen when two plates come together like this. They converge. Whereas divergent plate boundaries are constructive, convergent plate boundaries are destructive. Why are they destructive? Because when two plates come together, one of them is usually going to get pushed down under there and destroyed. Okay, so crust is being destroyed. It's gonna happen at a destructive plate boundary, at a convergent plate boundary. There are three kinds of colliding or converging plate boundaries, where you have an ocean and a continent coming together, where you have an ocean and an ocean coming together, or where you have a continent and a continent coming together. Okay, we'll go through each one. At an ocean and a continent, we talked about this a little bit yesterday. This happens when you have an oceanic plate and a continental plate coming towards one another, and when they come towards one another, the more dense of these two plates, which is the oceanic plate, is going to end up getting pushed underneath. We call that act subduction, and that creates those big, deep ocean trenches. Okay, where those ocean trenches happen tend to be, or they always happen at the border of a continent and at a continent and an ocean. But we call them subduction zones. Okay, where you have an oceanic plate and a continental plate coming together, that subduction happens at a trench, or what we call a subduction zone. Okay, whenever these guys come together, it's a lot of force and a lot of pressure, and even though the continental plate ends up winning, meaning the oceanic plate gets destroyed, it doesn't mean there's no damage to the continental plate. It gets plenty crumpled up. And as it gets crumpled up, you get the formation of these mountain ranges along the coast. Then, as the oceanic plate gets pushed underneath, it's hot, a lot of pressure down here, so it melts. And as it melts, it becomes less dense than the continent itself. So that melted oceanic plate rises up through the crust. And so you get the formation of volcanic mountains. So you get a lot of mountains formed right near those subduction zones on the continents. Okay, so that's what happens at an oceanic versus a continental plate. What about what happens at an oceanic versus an oceanic plate? Well, it's kind of the same thing. You have an oceanic plate coming this way and an oceanic plate coming this way. The only difference is that one of these plates is not noticeably more dense than the other one. But one of them is still going to be more dense than the other one. It's not, there are always going to be differences in density based on what makes up the rock in the crust in different places. So whichever piece of oceanic crust is more dense is going to get pushed under. Okay? There won't be a difference in density like there would be with an oceanic versus a continental collision, but one of them is still going to be more dense than the other. The more dense one is going to get pushed underneath, so we're going to get the creation of a trench. And then when that one that gets subducted gets pushed underneath there, it's going to melt and it's going to rise up. And as it rises up, it's going to form islands because we're out in the ocean, and those islands are going to be volcanic. We call these islands, these volcanic islands that form near a subduction zone, an island arc. And lots of the islands that you are aware of are island arcs. Places like Japan, the Japanese chain of islands, is an island arc. The Philippines is an island arc. The Aleutian Islands up in Alaska is an island arc. Okay? So you get the formation of volcanoes or volcanic activity near an oceanic versus an oceanic. Now, when you have a continental versus a continent coming together, neither one of these are dense. They're both light, or they're not light, but neither one of them are really dense. So when they come together, neither one of them is getting subducted. They just come together and they just push up. Okay? So you can think of like, in the example I used yesterday when you had the Honda Civic versus the Semi, and the Honda Civic was getting pushed under. This is like two Honda Civics, just 70 miles an hour head first. Boom! They're both gonna crash in, and they're gonna get crumpled and go up. That's exactly what happens at a continent versus a continent. So what happens there is you get the building of big, huge mountain ranges, and so some of the largest mountain ranges in the world are products of this type of collision, like the Himalayas, which would be in obviously at the intersection of the Indian plate versus the Asian plate. Those two plates are still moving towards one another, so the Himalayas are actually getting a little taller every year. So you get these big mountain ranges, but you don't get any volcanic activity at those plate boundaries because there's no subduction happening, right? You need to have subduction to have volcanic activity. The Alps are another example of a mountain range that's forming as the African plate moves upwards towards the Eurasian plate, and as they come together, the Alps are getting taller every year. So that's what happens when you have a convergent plate boundaries. And the final of these plate boundaries we want to talk about is called a transform plate boundary. And a transform plate boundary is what happens when you have two plates that aren't moving away from one another, and they're not moving towards one another. They're just like kind of grinding by each other, in different directions. And since no crust is going to be destroyed, no crust is going to be created, these are neither constructive nor destructive plate boundaries. The most famous type of plate boundaries, the most famous type of plate boundary that people talk about is the San Andreas fault. And we'll talk about the difference between faults and plate boundaries a little bit coming up. But the San Andreas fault is like a plate boundary here, where you've got the western side sort of hanging out and moving down to the south a little bit, and the western side pushing up to the northwest. So as they do, you don't think about them sliding nicely by one another. Think about them sort of grinding by one another. And there's a lot of pressure, obviously. Whenever that pressure builds up, there's going to be a release of energy, a massive amount of release of energy. And, of course, that energy is felt on the surface as an earthquake. So the San Andreas Fault is obviously known for earthquakes. They've made a lot of movies about that. So it's certainly the world's most famous transform plate boundary. I mean, The Rock made movies about it, so you know it's good, right? So I'm going to stop there. We'll be done with plate tectonics. We will continue on with, we'll talk about earthquakes, and we'll get into volcanoes coming up here. So we got a lot of exciting stuff coming up, and we will see you soon, okay?